I'd like to introduce my partner in crime, Ron Rogers. He's our VP of R&D for our Workstation and thin client business. And he too has been at HP for many years and a veteran of our Workstation business. So let's please welcome Ron.
Thank you. Well, welcome to Fort Collins. I've actually been with HP for 36 years, almost now, in a couple of months. So I have to make up for Jim's lack of 30 years at this point. And when I got here, I actually started working on something you'll go see down at the museum if you go on the tour. It's the 200 series, which is way over at the left side of the case. And once we introduced that in the early 80s, we think that was the beginning of the Workstation business. It was based on the Motorola 68K. And so through the years, we've worked on all the technology that goes in workstations here in Fort Collins. We've done RISC processors, we've done chipsets, operating systems, graphics, VLSI, and graphics boards. And so we have an intimate knowledge of the technology that's in our products. What I want to talk to you about today is a couple things. I want to first give you an idea of what you're going to see when you go on the lab tour. But I really want to talk a little bit about how we approach design and engineering of the Z workstations. So first of all, we have a kind of a philosophy which has three parts to it. The first thing that we think about when we approach design is that we have products that are professional standard computing. So they're designed for professional use case. We know our customers need a lot of performance, and computing is a critical tool for them to do their jobs. And there's really two kinds of performance people need. The first is that they're working on these very large problems, so they need a lot of capacity in terms of memory, CPU cores, graphics, and they're using that because they have heavy workloads, they're solving these big problems, they may be doing simulation, rendering, they may be working on oil and gas analysis. And then there are other customers we have that are actually more interested in performance in terms of interactivity and responsiveness. They want the machine to be very live and useful for them. And they may be working on things like process control, where they need some real-time response, or command and control for the military, or financial trading. And we have customers actually that need both at once. So there's a very demanding use case, it's a professional product, and in addition to that, there's a major investment customers make in these products, and so they want to see them have long product life, so that they get a return on that investment, and also because over the life of the products, they may repurpose them and they may upgrade them. So we have a wide range of performance needs for the professional use case. The second thing that we focus on is what we call customer-driven innovation. And we think about that in terms of the products we create, but also the way the products are used and the way they move through the value chain. And our R&D guys are extremely involved with customers. It's probably one of the most engaging R&D organizations I'm aware of. And we have lots of touch points with customers. About once a week, we have a customer actually come here to Fort Collins, and some of the R&D folks will go into the customer visit and present about technology. And the big advantage to us is that we can enter into an interactive discussion with customers. We can probe them on where are their bottlenecks or where are their challenges, and we can learn from them and ask follow-up questions so we get a really good understanding of what they're trying to do. The second thing we do is we have some of our technologists go out to what are called advisory councils, and we have those for the financial industry, for media and entertainment, for oil and gas. And at the advisory councils, we do something a little different. There we're actually able to expose to customers the long-term roadmaps. These are presentations under NDA. We talk about future technology from our partners, and we talk about how we're going to be evolving the architecture of our product and some of the choices we have to make. And we work with them to make those choices, and also sometimes we can take back from those visits information that we use to influence our technology partners like an Intel or a graphics supplier, so that we can help collectively meet the customer needs. And then a third touch point is when we get to the end of a project, like we've been in the last few months with these new programs that you're seeing today, we actually send them out to the ISV community, our software partners, and some of our key customers, and have them give feedback on those products. And we actually do make last-minute changes sometimes. In our last generation, for example, we were changing the physical structure of our product to fit in more memory in the new Intel architecture. We had had handles on the product before. We took one off the top of the 600 series. In that early review, one of the customers said, hey, I move these products around all the time. I really need that handle. Can't you do something? And so we made a last-minute change to add a handle back to that product. And the customer loved the fact that we were listening and responding to them. More often, we're looking at tuning up the system, the drivers and everything else in that last step. And then finally, we also have an environment where we have support cases that come into HP. If the customer has a very unique problem that's different, it may go through the first and second level support and come into the third level support, and our engineers get involved in that discussion. And we may learn from that there's some unique touch case or usage case, and I'll talk a little bit more about other examples. But in this context, we learn about what they're doing with products by seeing some of the struggles they may have once they deploy them. So that's an insight into the way we do innovation. The last thing that we focus on, and that is a passion for me, is a maniacal focus on quality. We have a passion about quality. We want to make sure that our products are extremely reliable. And actually, it harkens back. HP has had a long history of something called test, break, fix, where we want to test products to the breaking point so that we can see where the weak areas are, and then we improve those by adding margin so that they are more reliable for our customers and cover a wider set of usages. We have here in Fort Collins a very well documented set of tests we've developed over the years. We continuously improve and add to those tests. We share them with some of our partners, and they're evolving all the time because of the integration of new technology, these new usage models we discover, and also the increasing capability and complexity of our products. So, that's another thing we do. And then, as I mentioned before, we do third level support backup in R&D. So sometimes customers do things that are unexpected. So, for example, we have a software company that had this just moved to our products in the last generation, and they were running a Linux environment, and they had an application that was lagging when they were using it. They could see the machine slow down for a few seconds, and they didn't really understand what was going on. So we brought that in, reproduced it in the lab, and what we discovered was that they had a unique proprietary algorithm, and it happened to be using 5 of the 8 cores in the Intel processor, and they were cycling in and out of that workload very fast. And what was happening was that usage case with 5 cores actually puts the processor in turbo mode, and the power level of the processor was changing faster than anything we ever anticipated. It was actually worse than if you were running 8 cores without that turbo boost. And so what they were seeing was the processor would warm up. It would take a little while for fan control to catch up with that, and they'd see a lag in performance because the processor would throttle. So we were able to tune up our algorithm for fan control. We added some new test cases for the future, but that's an example of us going above and beyond to solve a very unique customer problem with the R&D team. Okay, so let me talk a little bit more about this, what we call the secret sauce of product development. And what do we mean by secret sauce? This is, when we think about our products, they have a capability that's beyond what you see in spec sheets. And the reason that this works for us is really made of some different parts. So first of all, again, we have a really clear understanding of the customers and the way they're using our products. And we know that they're using them in a way that may be different than other commercial PCs. They're using them in a 24/7 environment. They may be using them at max performance for an extended period of time. And so they also may be using applications in a workflow model where they have several things going on at once, or several parts of a suite of CAD and simulation running at the same time. So their usage model is different than most users of PCs. Secondly, expandability. Our customers are more likely to use 2-socket processors, terabytes of memory, multiple graphics cards, multiple displays. They're using many hard drives or solid-state devices, and they're also potentially using some of the new high-performance I/O like Thunderbolt or the Z-Turbo drive storage. So these are all things that are above and beyond what a normal user would be using. And then finally, they have a desire for some unique components, the enterprise quality components. Things like error-corrected memory, MLC, solid-state drives, professional graphics. And so we have a need and a process to integrate those into the solutions as well. So those are the differences, and the secret sauce really then is a convergence of several things. We understand the customer usage model very clearly. We had a long history and understand the technologies that make up workstations. And then we have this focus on quality and the customer experience so that we use all of that together to make our products extremely reliable, have great customer experience, and then form long-term relationships with our customers. Okay, one other aspect of what we do, and again, it may be fairly unique to HP, is that we approach design at the system level. We don't think about segmenting the design and having people work on each part of it. We want the team to work together and integrate all the parts to optimize the whole. So up on the screen here you see the new Z840. This is a picture of the inside of that product and also a shot of the inside of our Z1 Gen 2 all-in-one. And you know, when we did the new ID about 5 years ago, we completely redid our approach to the product and we thought about every aspect of the system. And when I talk about something like system design, if you look at toolless design, the Z840 has toolless everything. It has the toolless hard drive carriers, the toolless I/O slots. It has the toolless optical, toolless memory, and it also has the ability to even remove the motherboard without tools. So it is totally toolless, and that took a lot of work to make that work well for our customers. If you look at the all-in-one, it's almost as toolless. The only thing that isn't toolless in it is the motherboard. And what we had to do in that case was we had to fit MXM graphics, which had the right power envelope, into our all-in-one. Typically that's a small board inside a mobile workstation, but we wanted to make that accessible to users. So we found a way to package it up so that we could take that graphics and make it toolless as well. The other thing I want to talk about briefly is if you think about system design for something like the thermal and acoustics, we design these products where the subsystems all are managed independently. In the Z840, we actually have 12 fans in the base product that are comprised of different thermal control zones. And the reason we do that is because the workload within a workstation may be at some time in the processor, sometime in the memory, sometime in the graphics. And by having all of those fans and all that control, we can optimize the cooling to keep the product as quiet as possible and guarantee its reliability. And so that's an important part of that. And in the Z1, we have a similar situation. We have 4 different thermal zones. So that approach to system design allows us to have outstanding reliability, great customer experience. Okay, on the tour today, you're going to see some of this in action. But we have an approach to design where we have lots of different touch points for each of the subsystems in testing. For example, the motherboard design integrity is a place where we look at the signals on the board and we use that technique of margining to make sure we have the absolute best margin and therefore the ultimate reliability. We have, in the last generation, made some movements to the green technology and we were able to actually improve our margin. We made that move to green. If you look at system design reliability, in this case we're talking about the mechanical tests where we're making products rugged for a factory floor or for flying in a helicopter for meeting entertainment. We also test things in shock, which is a placeholder for people that drop or move their products. And we take products through that entire suite of tests and make sure that they work at the end of that. And also we look at the wear that happens to the products and make sure that they're going to continue to work for years afterwards. And so we've done things like increase the gold plating on our connectors to make the machines more reliable. The proprietary integration testing, that's really where we take every system element, the memory, the graphics, the processor, load them up to the max, test them all in combinations, and make sure the system continues to perform. Enterprise class performance, or components I touched on before, we have specific directed tests to test the error correcting memory or the SLC storage. The critical margining is an area, again, we think is probably unique. We look at some systems where we vary the voltage to the board, the temperature, and the frequency that we operate simultaneously. And we test beyond what the industry specs are. And we, as a result of that, work with our suppliers. If you take a system like memory, when we initially test memory DIMMs, about 30% of them don't pass our standard for memory test. We go back and work with the suppliers and improve the margin by changing the setup of their memory. And ultimately what we end up with is about 10% of the memory that won't meet our standards even after that second step. So we then only use the best components. So that's another way that we generate the reliability in our systems. And then finally, a material analysis. Here we use chemical, mechanical, and X-ray analysis to look at components. And we take that knowledge to choose the absolute best components. We choose the best tier 1 suppliers of some of the components like inductors or capacitors. And we use only the best in our designs, and we get another level of reliability from that. Okay, so today, again, you're going to see all of this in your lab tour. We have all these test facilities here on site, And the fact that we have them on site is a major investment for us, but it helps us quickly resolve any problems we have during product development. It gives us more capability to make sure the products are the highest quality before release. We've invested a lot in the proprietary test methods using our experience in the business. And we're really excited about the quality that we're going to generate on this next set of products. We've made some big changes in those last year to be more efficient in tests. So thank you.